All right, so this will be the 13th lesson, I believe, in the statistics series. We're almost done with statistics. This lesson is going to be on probabilities. The objective for the lesson is to determine the experimental and theoretical probabilities of simple experiments. And we'll do this by using some of the tools that we use, well, I defined for you earlier in the previous lesson. First thing we're going to look at is the experimental probability, which is essentially what really happened when you perform an experiment or you gather the data. Say, for example, you conduct an experiment where you have a certain number of trials. You take a coin, a pair coin, and you toss it in the air multiple times, or maybe 1,000 times, maybe 50 times, how much ever times. You toss it in the air multiple times, and you just record whether it lands heads or whether it lands tails. And then once you do that, you'd be able to get the fraction of successful trials that you're interested in. So like if you're interested in heads, you will find the successful trials for heads and you compare it to the total trials that you do, and that will give you the experimental probability. So simple formula is that you take the number of successful trials in your experiment and your total number of experiments, and that will give you the probability of that event happening. Let's look at an example where you say, assume you flip a fair coin 50 times and heads was obtained 28 times. So then that means the experimental probability is 28 out of 50, which is 0.56. So that's the probability of obtaining a heads in this experiment. It's not to say that the coin is not fair, right? But this is just what the experiment shows. Let's look at the theoretical probability. The theoretical probability for the event is under the assumption that every possible outcome has an equally likely chance to happen. And what we do is we base our calculations off of that. You don't need to see it roll. You don't need to see a coin roll. You don't need to see a dice. Sorry, said that wrong. You don't need to see a coin flip, and you don't need to see a dice roll. You just need to figure out how many possible outcomes in the experiment that you're doing. You need to figure out what is the success that you're looking for, and then you just simply do the calculation. So this is number of variable outcomes divided by the total possible outcomes. So you have formulas that can give you total possible outcomes for situations where there are multiple coins. So let's say a fair 6-sided die is rolled once, and the probability of rolling at 3. We know it have 1, 3 on a die. We know it have 6 faces on the die. That means you have an approximate probability of 0.167. Right? So that is the theoretical probability of that die. Right? We didn't conduct an experiment. We didn't roll any dice or anything like that. This is the theoretical value that you're going to get. Right? It makes the assumption based on the fairness of every possible outcome. Now, you can have different types of events when you're doing experiments. You can have mutually exclusive events. And an exclusive event is one where if event A happens, event B cannot happen. Right? So a simple example would be like you're flipping a coin. If you flip the coin and you get heads, then that means you're not going to get tails at the same time you flip that one coin. Right? So whenever an event A happens, event B cannot happen. So the probability of getting either event A or event B is just simply the sum of all probabilities. Right? And event A and event B is an empty set because they don't have anything in common. They don't happen at the same time. Each event does not happen at the same time. So a single card is drawn from a standard 52 card deck. What is the probability of drawing a club or a heart? So the probability of drawing a heart is 13 there are 13 heart ranks in the 52 cards, and there are 13 club ranks in the 52 cards. So the probability of either choosing 13 of hearts or 13 of the clubs is just simply 13 plus 13, which is 26. So there are 26 possible outcomes of success. Now remember, the success is getting a heart or getting a club. So if there's 13 hearts and there are 13 clubs, that's 26 possible, 13 plus 13, 26 possible outcomes. And there are 52 cards in the deck, so 26 over 52, and that is a half. So there's a probability of 50%, a half, or 0.5 of pulling a club or a heart from the deck. Now, the other type of event that we can deal with is independent events. Now, independent events do not influence each other in any way. For example, if you flip a coin, it does not change the likelihood of rolling a certain number when you flip it a second time. Or maybe if it is that you have a dice that roll in right after. So if you flip a coin and you roll a dice, it doesn't interfere with each other, right? So when events are truly independent, we multiply their probabilities to find the probability of both happening together. So let's say probability of event A and event B happening at the same time. For independent events, we take event probability of A and we take probability of B and we multiply them by each other, right? So for this is the multiplication rule for if event A and event B are not, for if event A and event B are independent of each other. And since we're looking at that, let's look at a quick example. If we roll a six-sided die and flip a fair coin at the same time, what is the probability of getting a 3 and a heads? There is a 1 in 6 chance of obtaining 3, and there's a 1 in 2 chance of obtaining a head. So that means 1 by 1, 1, 6 by 2, 12, and that is the probability 1 over 12. 1 12 is the probability of getting a 3 and a heads. And that's it. We learn what an experimental probability is, we learn what a theoretical probability is, and we learn about exclusive events and independent events. And anything for probability going forward is something that you can do very easily. All right, so that's it. Thank you for joining me in this lesson. And just a reminder, if you find the content useful, please let me know. And if you have any questions, feel free to ask, and I'll be happy to help. And I'll see you in the next lesson where we'll discuss inferences.